Well, I think part 1 lived up to the hype with y equals 1 over x and asymptotes. Next up, parabolas like y equals x squared and, with any luck, some harmony. But we have made progress identifying f, that distance from the focus to the intercept, and its friends. We'll get back to the parabola in a minute. First, let's state the obvious. Addition and subtraction are different, even if you guys only ever want to talk about eccentricities. See the difference? Can we just say that b is imaginary? I think that could work, but too bad it would not solve all our problems. For example, why does a need to outrank b for ellipses? It's not obvious if you look at this equation, but if you go back to try to find c and e, yeah, a has to be bigger because it's defined as the semi-major axis, the longer axis. But we can see more shapes by rotating the axes. That's just swapping the x's and the y's, right? Well, no, rotation is something we worked out earlier. It involves a negative sign, which in this case is squared. So yeah, I guess we kind of are just swapping x and y here, but wow, we're at it. Let's use h and k to translate these graphs around. That's pretty, but is it harmony? I know. Let's graph these guys with the same a's and b's. So we're going to have the same a's and b's, only changing the sign. Okay, a is the intercept, and that's why they touch. Reminders about c, e, and d. Let's go. That was fun, I think. But a few things really stood out or stood up. Here, e is going to infinity. Here, it goes to 0. These are nice bookends to our list. But wait a minute, is a straight line really a conic section? And there's another crunch point too, right here. Both eccentricities this time are approaching 1. A is much bigger from b, but how are these shapes parabolic? Here's how. Wait a minute, that's just an ellipse in the vertical form. Let's center it at a focus, k equals c. Next, an expression for b to hold on to, and f, that guy again. Substitution and algebra, lots of it. But finally, we're getting to the good part. We're going to let a go to infinity, c will go there too, e goes to 1, just like we wanted, and f will go to 0. Let's go. See? And algebraically, that's how that y squared term went to 0, giving us a parabola. And a good reason for not writing this equation with the a's and the b's. Infinite a? No, thank you. The same steps would work out from the other side of eccentricity equals 1. So a parabola really is both an ellipse and a hyperbola. How about that? See, it's the same shape. And our to-do list is getting to done. But what about y equals x squared? We'll zoom in to see f and d prime in action, and then rotate to find f, which is small. But there it is. That's the focus. Oh, f for focus, I get it. And our favorite eccentricity equation finds the directrix. D prime must be 2f, which is how we'll show that the distance to the focus divided by the distance to the directrix is 1. Eccentricity is 1. And we are done, except for the polar equation. Looks like another rotation and translation. Oh yeah, centered at the focus. I could get used to that. Yeah, let's do that. Harmony. And we could rewrite this equation like that. I derived both these equations in the ellipse video. I think it's part 1, by the way. And we could rewrite it like that. I like the amplitude and the eccentricity, but that would get us into trouble at e equals 1 and a equals infinity. So this equation probably is our best bet for that harmony we were so eager to find.